Hello, Integrated Math 3 and Integrated Math 3 Plus. Welcome to Lesson 12-1. Yay! Where we're going to start exploring exponential functions. To get this party started, actually, before we even get here, I'm going to come over here. I would like you to take a look at question number 1 on student activity sheet number 1. Here we've got Erin. She gets a $50 check from her parents for her birthday, and she wants to save to buy an MP3 player. So she gets a job walking her neighbor's dog and earns $15 per week. So what I'd like you to do is I'd like you to fill in the table. She starts with 50, and then of course she gets another 15, 1-5 every week. And then I'd like you to graph that table and see if you can give me a function rule that would fit it. So go ahead and hit pause to work this out, and then hit play when you're ready to check your work. All right, people. So let's see what we got here. We're going to start off with $50, right? So $50. But we're going to add 15 each week. So 50 plus the 15 means that she's going to have $65. But the next week she earns another 15, which brings her up to $80. Again, if you need a calculator to double check your numbers or to double check my numbers, that's not the worst thing ever. Another 15 is going to take her up to 95. Another 15 is going to take her up to 110. Another 15 will take her up to 125. So it looks like if I've got x, then my function rule is I'm started off with 50, and then of course we're going to add 15 times however many weeks it's been. Yay! Oh, and we're also asked to graph the data, so let's graph the data. So we've got 0, 50, it starts right there. Make my circle a little bigger. At 1 week, we're up to $65. So it's 60 and 5 is going to give me a little bit more right there. 2 weeks, we're up to $80, which puts us right about there. 3 weeks puts us up to 95, about there. 4 weeks puts us up to $110, and 5 weeks puts us up to 125. So about there. And sure enough, you can see this makes a nice little line. Yay, yay, yay. It does make a nice little line, which fits our function that we've got going on here. I'm going to erase because I don't need all of that. Wow, I thought that was red. It definitely has kind of an orangey feel to it. And of course, we can double check our work. If we just come over here, oopsie, there we go. If we just come over here, you can see it makes this nice line, which we're going to call d of x. But yeah, 50 plus 15x. So it makes this nice linear function. So we're going to continue looking a little bit at linear functions, but we're really going to start focusing on other functions that we know. We know linear, we know quadratic, and we're going to start focusing on some other ones too. So Barry and Red, they're studying population growth in their science class, and each student in the class got to choose a type of insect to raise for 4 weeks. So Barry went with fruit flies, and Red decided to raise fire ants. I'm a little worried about Red and what he might do with those. They both started with 20 insects, so I hope you're making notes here. Question 2. We're going to answer questions 2 and 3 and a few others as we go here. So they both started with 20 insects, which would help you out with question 2. And then they counted the population once each week. So I'm going to run this animation, and you're going to take notes there on your table on number 3, and we're going to see what happens here with our lovely little guys. I'm going to get rid of that. So week 1, we got 20 fruit flies, but Barry has 40 fruit flies week 1. Week 2 is 60. Week 3, he's got 80. And week 4, he's got 100. So he starts off with 20 fruit flies, and after 1 week, he's got 40. After 2 weeks, he's got 60. After 3 weeks, he's got 80. And after 4 weeks, he has 100 of them. Now, this doesn't fill out your entire table. It only fills out part of it. But if you flip over to 4, you're going to have to flip back and forth here a little bit with 3 and 4. If you flip over to 4, you'll notice there's a graph. Can you go ahead and graph your fruit fly data? Go ahead and hit pause. I'll give you a moment to get your graph together there on number 4, and then I'll hit play when you're ready to check it. All right. So here's my graph. I plotted my points 0, 20, 140, 260, 380, and 4, 100. Interesting. I think this means you can also answer questions 5 and 6 at this point in time. I'll come to the questions for that later on, but if you want to hit pause and answer questions 5 and 6, now might be a good time to do that. But if you're ready to move on, let's go to Barry and his fire ants. I'm worried about Barry and his fire ants. Let's come back to number 3 and finish filling in the table for Barry's fire ants. So again, Barry starts off with 20 fire ants, but after 1 week, he's got 40. After 2 weeks, he has 80. After 3 weeks, he has 160. And after 4 weeks, Barry has 320 fire ants, which I don't think we can even fit on the screen. Again, I'm a little worried about what Barry's going to do with his fire ants, but you know, it is what it is. So hopefully you got your table filled in. Oh, and you know what we're going to do now. If you've got your table filled in, I want you to use the week for your X coordinate, the fire ants for your Y coordinate, and go ahead and put it on the same table. On number 4, put it right on top of your fruit fly graph. Put your fire ants right there on top of it. So again, hit pause to work that out, and then hit play when you're ready to check your work. So I plotted my points 0, 20, started in the same spot, 140, still the same, but 280, 3, 160, and 4, 320 definitely have a bit of a departure here from our fire ants. Now I have my fire ants in red and my fruit flies in blue just to kind of help distinguish it. So how are the growth rates of the fruit fly and the fire ants comparing? You may or may not have already answered questions 5 and 6. If you haven't, do it now. And also answer questions 7 and 8. Go ahead and hit pause to give some thought to these questions and then hit play when you're ready to check your work. All right, let's see how we're doing here. So I noticed that with my fruit flies that it increased by 20 each week. That we added 20, added 20, added 20, added 20, which gave us a nice little linear function. It gave us a nice line, didn't it? But when I did the fire ants, I was actually multiplying by 2 every time. Times 2, times 2, times 2, times 2. And so when I graphed it, it gave me this curve. Like it started out all right, and then it just went crazy steep. So while my fruit flies then can be modeled by a linear function, it means that my fire ants actually have to be modeled by something else. It's going to be modeled by an exponential function, which you probably already knew given the title of the lesson. But yeah, because we're multiplying by 2 every time, we're always multiplying by the same number, we can model it with an exponential function. So exponential functions actually model a lot of different situations. Now, please notice, my linear function had a constant difference, right? We're constantly adding 20. But my exponential function has a constant multiplier. I'm constantly multiplying by 2. I'm always multiplying by the same thing. And so actually, exponential functions naturally occur all over the place, from spreading rumors to growing populations to depreciating car values to radioactive decay. Oh my gosh, exponential functions are all over the place. And so that's what we're going to be doing this unit, is kind of playing with exponential functions and looking at all the different places they show up. So on a linear function, we have a constant rate of change. But on an exponential function, our rate of change is not constant, it's exponential. So we're going to talk a little bit about what that means. So if you are looking at question number 1 on student activity sheet 2, there is a lovely table there on question number 1. Now you already worked out some of these, like we already did the number of weeks and the number of fruit flies and the number of fire ants. But can you please fill in the constant addend column and the constant multiplier column? Just take a moment to fill those out and then hit play when you're ready to check your work. So I'm going to hit play. Go! So for our fruit flies, we were constantly adding 20, add 20, add 20, add 20. So we were constantly adding 20, whereas with my fire ants, our constant multiplier was 2. We were constantly multiplying 2. So what I'd like you to do at this point, can you go to question 2? I'm going to go to question 2. Pardon me. Let's take a moment just to focus on our fruit flies and that whole add 20, add 20, add 20. Can you write a linear function that would tell us the number of fruit flies we have depending upon the number of weeks? Go ahead and hit pause to write a nice little linear function for your fruit flies, and then hit play when you're ready to check your work. All right, so for my fruit flies, I started off with 20, and then I was adding 20 every week. So I did 20x plus 20, because 20 is where we started off with, right, our initial value. And then because I kept adding 20 for every week that we kept this experiment going, I did 20x. Yay. But let's see if we can figure out this exponential thing, because we said it had a constant multiplier. It didn't have a constant rate of change, but it did have a constant multiplier, which made things exponential. Let's see if we can figure out why it's making things exponential. So if you go over to question 3, you have this table that's already been started for you, and you already have some of these pieces. I would like you to continue the process and then see if you can use that process to help you get a function rule. Go ahead and hit pause to work this out, and then hit play when you're ready to check your work. So we started off with 20, and then we had 2 times 20. But then we doubled our 2 times 20 to get 80. But that means I'm going to double my 2 times 2 times 20 to get 160. And then we're going to double that, so 2 times 2 times 2 times 2 times 20 to get my 320. And hopefully you're noticing a pattern here. The 20 is always hanging out. I can't get rid of the 20. I can't get rid of the 20. But I'm just going to keep multiplying 2's, and the number of 2's I multiply is going to be based on how many weeks we're in there. So that means I'm just going to keep multiplying 2's, and that 20 is going to stay the same. So that means that I've got 20 for what I started off with. But as far as how many 2's I multiply, it depends on the number of weeks. So I can rewrite that as an exponent, so 2 to the x power. And this is why that constant rate of change gives us an exponential equation. My x literally went right into the exponent. All right, guys, I hope you found this helpful, and I hope you found this useful. If you got questions or concerns, please feel free to email me or come see me after school Tuesdays and Thursdays. You know I'll be around, and I'll see you soon. Bye.